Hello everyone, and thank you for attending my talk about minimal viable security for Python applications. The goal of this talk is to share with you an iterative approach to security called minimal viable security and how to practically implement it. Taking as an example a fast API-based application that I want to secure by adding a few critical security controls. So let's get started. But first of all, let me thank the Conf42 organizers for a carefully planned event full of excellent topics and speakers. In these challenging times, it's far from being granted, so well done. Let me now briefly introduce myself. I'm David Melamed, one of the co-founders and CTO at JIT, a dev-first cybersecurity company. I have a PhD in bioinformatics and I'm passionate about technology and security for a few years. Previously, I worked as a senior technical leader in the city office at Cisco, and before that at CloudLock, where I have built cloud applications at scale and led some strategic projects. I love to share my knowledge and experience, and in the past, I was also involved in a few communities like Python and AWS in Israel. So, when you should start to care about security, I'm sure that's usually not the first thing that comes to mind when you start building a new application. If I ask an engineer what is his main concern while writing his application, it probably would mention functional bugs and performance way before security. And that's also the way startups are picking up their priority. You need to deliver business value to survive, accepting the risk of security at least until your customers start asking about it or when you face your first security incident. That's mainly because security is hard, and yet it's an ongoing concern. It's not something you can deal with once and tick a checkbox. It's a journey and a continuous investment. But its cost is lower if you start managing it on your first day, not necessarily handling everything, but at least be aware of what needs to be done so that you don't spend your time catching up. But don't try to boil the ocean on your first day. Start minimal and add security iteratively. Let's take an example. This is a typical cloud application. Starts with the manager granting the developer access to commit his code. The code is stored into some SCM like GitHub or GitLab. Upon commits, the CI pipeline is triggered, and after merging the code, the application is deployed in the cloud provider. In our case, the application is containerized, so the CI pipeline builds the Docker image and stores it into the container registry, which is pulled by the microservice at runtime. Microservice states are then persisted in the database and are communicating with third-party services and between each other and are exporting through an API gateway some external endpoint for external users. Now, this environment has multiple risks in each area, and I want to mention a few one. So first of all, if you're looking at the grant access at the manager, well, let's say that right now he granted access to the developer, but let's say the developer is leaving the company, he may forget to remove his access, and therefore there may be some unauthorized access. For the developer itself, well, you have the risk of credentials theft, of course, but also the dependency type was quoting if he mistyped name of a package and now he got some malicious package inside his code. For the code itself, you have code vulnerabilities that are really common and infrastructure misconfiguration that are part of infrastructure as code. In the CI/CD pipeline, you have supply chain attack and credential theft as well. And in the cloud provider and the runtime, you have a lot of different risks, ranging from data leakage to corrupted data for multi-tenancy cases and data loss and leakage also. And finally, for the users, you have unauthorized access and man-in-the-middle attacks. So a wide range of risks, and those areas that are showing the different risk can actually be grouped in different layers. So you have the layer of the code, the pipeline, the runtime, the third party, and the operations. Now, look at the chart here, and it will show you all sorts of security controls that you need to add along the SDLC. But if you start with a minimal viable set of controls and iterate from that, it seems way more likely that you will be able to succeed in improving gradually the security of your product. So what does it mean? Well, like a minimal viable product or MVP, security can start with something small in order to deliver a product with enough critical security controls to be viable. You won't embarrass yourself in front of your users. This is an example of list that includes some critical controls. This envious approach is that something that we will follow for the rest of the talk, and I will demo a few of them that are highlighted here in this talk. What's their goal and how to add them in your CI/CD pipeline. So I'll talk about static code analysis, secret detection, dependency check, API security, and MFA for GitHub. So this is the application that I want to demonstrate today. It's a movie application based on a fast API framework that mostly return a list of movies and the name of the actor that are playing in a specific movie. It's a containerized application that is providing a couple of HTTP endpoints. Now, I want to talk about how to secure this application. For that, I will show you and demonstrate how to add those different controls. So you have Bandit that I will use for static code analysis, Gitleaks for detecting secrets, Kicks for the infrastructure, Safety for dependency check, Zap that will be used for API security, and finally I will write some custom control in order to check for MFA in GitHub. But I want to dive a little bit more deep into each one of these controls. So let's start. First of all, static analysis. This is used to detect vulnerabilities in code using existing patterns. For this demo, we'll use Bandit, which scans Python code. It's an open source project with more than 30 built-in rules to detect vulnerabilities. Next, for security detection, we'll use Gitleaks, which comes with almost 100 regex expressions for the common popular third-party services like AWS, Slack, GitHub, and so on. If you have some infrastructure as code that is expressed as code, then it should be also possible to detect misconfiguration early by scanning the code instead of having to look for misconfigurations at runtime. One of the popular tools here are Kicks. I'll not show that specifically in this demo, but it works in a very similar way than the Bandits that I will demonstrate. Just for the record, Kicks supports many infrastructure types from CloudFormation, Terraform, Kubernetes, Docker, and Ansible. And it includes more than 2,000 built-in queries. Next, we want to check for vulnerabilities in our packages. And for that, we'll leverage the OSS project called Safety. It detects publicly disclosed vulnerabilities that are contained within the project dependencies. And you have actually two versions. One that is open source with a monthly update, or commercial with something that is updated more frequently. Next, I will want to talk about runtime monitoring. So some vulnerabilities can only be detected at runtime. For example, some of the cross-site scripting and some of the SQL injections. So for this demo, we'll use the OWASP project called Zap for Z attack proxy that includes about 17 built-in rules and uses the Open API specification in order to pull the different endpoints that the application is exposing. And finally, let's talk about the SAM security. So let's say in this case, Github Security. Because with rising supply chain attacks, it's critical to ensure that your GitHub service and the pipeline are also properly secured. And for that, the minimum would be to start by making sure that all your users are enabling MFA in all the services and specifically into GitHub. So for this demo, I will write a custom control that will basically list the GitHub users that don't have MFA enabled. And this control will fail if the list is not empty. And that will leverage a token that I will add to the GitHub secret in order to get access to the GitHub API. So now we talked about that, let's go into the demo. And just for the record, everything that I will show you here is available in the publicly repository that the address is mentioned here. Okay, so the first thing that I want to show you is actually the application. Okay, so it's a simple application. This is the main APIs, and you can see that. It uses database movies.db that includes some data from IMDb. And basically, you have here a Docker file in order to build it. Okay, it uses UVcorn in order to run it. It includes some secret for AWS that will probably be detected by my control. And in terms of the API itself, the first endpoint is returning the number of movies in database. The second one is used to look for a specific movie, and then to return the list of the stars in the movie. So let's see it in action. Let me start by running my application. So okay, here. Okay, so my application is running on port 8000, and let's now go to the browser. So if I'm going here in docs, I should be able to see the different endpoints that my application is exposing. And now let's just make sure that it works properly. If I'm going to movies count, I'm returning the number of movies in the database. If I'm going to movie title equal Titanic, yeah, like that, then I will get the list of all the movies with the different release dates. Let's say I want this one, so I'm going to this, and I want the list of stars in it. This is the list of the stars that are playing in this movie. So the API is working correctly, right? Now let's go back to the code. So these are the requirements to make it work. Pay attention, I added a special here requirement of a package called Alexa that has some vulnerability, and this is for the purpose of the demo. But you can imagine that you have any package here that may have some vulnerability. Now, I want to show you also what I will use in order to implement all my controls. So this is the GitHub action workflow called security.yaml that is triggered on push. And now I want to show you the different jobs that are included here. So first of all, you have the SAST jobs. And this is using an action that is encapsulating the Bandit package of Python. And here I'm adding a few parameters so that the output will be in JSON and in a file called output.json. And then I'm using this action called upload artifact in order to upload the result into the GitHub artifacts. And basically, if there is any vulnerability here that Bandit will find in the current folder, then it will return an exit code of 1, and so this job will fail. The second job is for secret, and here I'm also using another built-in action that was written by the guy who actually wrote the project. And so here it's the same thing. If it fails, it returns an exit code of 1, and then the job will also fail. The third thing that I'm doing here is using Zap. So it's the API scanner. And for this, what I did previously is that I packaged my my application into a container using the Docker file that was included here. And basically, I uploaded that to the GitHub container registry. And here what I'm doing is that I'm using the option of service container that GitHub Action is providing. So I'm loading my container here as a service. I'm making sure that it's working, so it's loaded properly by adding a health check command. Okay, and I'm using the count endpoint to make sure that I have some results. And here I'm mapping the port 80 to port 8089. And then in the steps of the job, I'm using the built-in action provided by SAP. And here I'm providing the fact that I'm using OpenAPI, and this is my target. And as you can see, I'm using localhost with the port that I specified here with OpenAPI JSON that is provided by Fast API in order to scan my API. And here also I'm specifying that I want fail action true, meaning that if there are some issues, then it will return an exit code of 1 and my job will fail. Next, SCA, I'm using here safety, so I'm installing safety directly, and I want to scan the requirements.txt and return a JSON format into a file called output.json, and then I'm uploading that as an artifact. And finally, this is my custom control. As you'll see, it's very simple. I previously created a token called my OR token here that I stored in the GitHub secrets, and my token has a scope of admin read so that I can call the API for the list of users in my organization. And this is a simple code in JavaScript, not in Python, though we could do the same thing in Python. But here we're leveraging the GitHub script action that is built for JavaScript. So basically here I'm just calling an API of a list member for a specific organization with a filter of 2FA disabled. So this will only return results in an array if there are users that don't have MFA enabled. And so if this is the case, then for each one I want to show a message with the user don't have MFA enabled, and then in that case I want to exit with 1, otherwise with 0. So that was the main file. Let's see it in action inside GitHub itself. So let's go back to the browser. And this is the repository that I talked about. Here you can see the requirements. You can see the main code of the application. This is the main code of the application, everything I showed you before. These are the workflows here that I just prescribed. And now let's see what happened. It already ran once. So let's see what happened here. So basically all the jobs failed, and this is what I expected because this is a Goat project, so it's flowed by design. And let's see each of the results. So let's start with the first one. The first one is SAST, so it's running Bandit. For this one, it's returning directly the results in a file and as an artifact. So let's go back and let's see the results. So this is the artifact. I can download it. Let's download it. And now I want to see the results. So let's see the results in the terminal, for example. So here I have my output, and I want to do like that, output. And what I can see here is that I have 3 issues that Bandit detected with the medium confidence. If I'm looking at the details, I will see that it discovered a few SQL injection, right? Possible SQL injection vector, okay? And the reason for that, if I'm going back to the code, is that in the code, I actually left this part as part of formatting. So potentially someone can introduce some malicious input here, especially because this comes from the user input. So basically, there's a SQL injection here possible. Right. So this is what Bandit found. Let's go back to the browser, and now let's go to the secret one. So the secret, let's see the results here, and we can see that yes, basically there is 2 secrets that have been found that are redacted, but I can find exactly this is the AWS key. Okay, and so I can go and not only remove the key, because that won't be enough, because now it's on GitHub, so you never know what can happen. But I need probably to recycle the key, right? So disable the key and create a new one. The third job is the API security scanner, so it's a ZAP scan. So I could read here the results, but basically ZAP is also uploading some artifact, and also it's creating an issue here. So I can check the issue here. This is probably the last one. Let's go to the last one. And as you can see, it found also some SQL injection, as well as a couple of other issues that I need to fix in my code. Okay, and you can see what happened here is that it tried different URLs, and that's basically based on the OpenAPI specification that the application is returning. So if I'm coming back here, that's one of the features that Fast API is returning. Here I can see the OpenAPI specification, which returns the list of all the endpoints that this API is returning, and that helps ZAP find the exact targets that it needs to scan. Okay, and that's how it knows that there's a movie's title equals and this attempt to do some SQL injection. Let's go back to the actions here and see the next thing. So now we're going to dependency check. Dependency check also is returning some artifact. So let's get here to see the artifact itself. Okay, so that's safety. I'll also download it. And let's show the results. Okay. Yeah. And now let's see what I have here. And this is the Alexa package that I had in my requirements. So that's a package that helps writing Alexa skills, for example. But here the problem is that it had some Pi OpenSSL vulnerability. So if I want to get it fixed, I need to bump the version to the latest one, probably, or one of the latest one, which is at least 0.40. And now I can also check the last of the controls. So this is the MFA checker. And as you can see here, it failed, and it tells me that this specific user doesn't have MFA enabled. So also here, a very simple fix is actually to go and tell this user to enable MFA so that the checks will pass. Okay, so these are 4 different actions that I added in my 4 different actions that I added in my pipeline. Basically, by the way, the MFA checker shouldn't be triggered on push because it doesn't change every time you're pushing some code. It should be run on schedule. But that was just faster to show you all the different controls like that in one place. Okay, so coming back to the slides a little bit. What I show you is that there are a lot of security controls that you can add to your pipelines, and there are a lot of different areas where you should add some controls. But basically, in order to be able to secure your project from D0, what you can do is start with something minimal, and this something minimal is an example of something minimal is what I showed in this talk. You taking as an example a couple of different controls and how it's easy to actually implement them and add them into your GitHub Action CI pipeline. Of course, it works with other type of CI pipeline. It can work with GitLab or with Bucket, with any other CI pipeline the same way. These are actually, most of them are built-in actions, but the code is available, so it's at the end, it's just containers, so you can definitely run them any place you want. Here at JIT, we also follow the same MVS approach. We built a continuous security platform for developers in order to help them secure the applications they are building, automating the integration of those controls in your environment and removing the noise and unifying their interface. And if you want to know more about us, then go to our website, jit.io. If you want to test our platform, send us a quick email, jitmein@jit.io. And if, like all of us, you want to help developers with the security, then you're more than welcome to join our team because we need you. That's it. Thank you very much for your time. I hope it will help you increase the security of your application from the zero. Don't wait any longer because you can start already today. Thank you very much and see you soon. Bye-bye.